don't think I like this camera. It's just zooming in too close. Why did it zoom? I had the flag up there and now it's cut. Well, happy Friday. Welcome back to the shop. First up, viewer appreciation. I'm just going to thank Noel here for what he sent. So I'll take you over to the bench, show you what he sent, which is going to really help out in the shop. Then I've got just kind of an update on the lathe and what was done with this new feed system and the finish that I can get on 1018. I think you'll find that interesting. And then, as the title says, making a chuck stop. Hope you guys enjoy. It's kind of a fun, quick project, what you can do when you have a piece of scrap kicking around in the drawer. Just got a care package from a subscriber. I'm blown away here, Noel, because this is a lot of money here, but and a lot of time. I guess this guy used to teach machining and so on, and he got all over my speeds and feeds video. The first part, second part gets released today, but man, it's going to take quite a while for me to go through all of this stuff. But this is great reference material, cutting speeds, metric sizes, fractional drills. Boy, look at that, for every single size, 1/8 inch revolutions per minute. So yeah, RPM, 1833. What do you do if you go up to a 1/2 inch? 229 RPM. What is, feet per minute. Oh, I guess that's how fast you're going in to the material. So, boy, it's going to be a while to get through all of this material. This book, too. This is crazy here. Everything you ever want to know about machining, tapping. Look at all this stuff. Adjustable reamers. It looks like it's, yeah, it's adjustable. Wow. So this is a whole college course here that I'm sure takes a long time to go through, but I'm going to be going through this stuff tonight, looking at it all. This is just insane what this is. The machining fundamentals, more machining fundamentals. Too many books. Good. Oh boy, questions and answers here. Cutting fluids, jigs. So this is going to take me up quite a few notches here. Yeah, this must have been a test book or something. Oh, they got stuff you could make in here. How nice is that? Layout. Oh, I'm going to really get into this one. What else? This is instructor's manual. Whoa. J's and Bates. More formulas and stuff, gear nomenclature. Some of it I'm not going to get into, I know that. What is this? Hand machining? Oh boy. Well, I think everything and anything I ever wanted to know about machining is right here. Hey, what's the last one? Workbook. Good grief. Yeah, these are all the test questions or something. Yeah, man, if I can start answering some of these questions, I know I've got it mastered. So, Noel, thank you so much. This is going to be quite a while for me to go through all this material, but this is incredible. All right, so playing with speed. Let me see, because there's no overhead light on it. It was reflecting earlier. So I just kind of doing an experiment, and I've also figured out how to angle the camera down closer. Working with what Noel sent me, this little book, machinist book, which really is a great book. Boy, there's a lot of good stuff in here. So everybody talks about speeds and feeds, and I'm just trying to follow up on this. Everybody talks about speeds, which is take a point on the rotating object, you know, your stock, a point, and they always say surface feet per minute. So it's how far that point will travel in 1 minute. So for this, I just picked the alloy steel and said, you know, 1/2 inch diameter. Of course, the larger diameters and the smaller diameters, you have to run at a different RPM. So did the calculations for the steel, 1018. It says 191, I said 200 and 1/2 inch, so wound up being around 800 RPM. Pulled the tack out, set the lathe for 800 RPM, and I've also done all the calculations before on the feed rate, what frequency I need to put on that box to get specific speeds. And I said I want to move in, oh okay, nothing clearly states what feed rate you should be using. I was figuring it'd be a table like this, but it's not. I stumbled across a YouTube video showing this G-Wizard calculator for turning, milling, and so on. And the feed rate, when you ran that calculator, it depended upon what surface finish you wanted, how many micro inches, so to speak, of roughness. So just for grins and giggles, I said I want to move in 1/10 of a thousandth per revolution for this 800 RPM. So I ran the math and came up with the frequency, put it in there, and lo and behold, look at this, 1018 is starting to give me a mirror finish rather than this other stuff. And you can't feel anything. I can see stuff in it, but I cannot feel any marks in this at all. And I was starting to bump up the feed rate because that's incredibly slow moving. And it's probably going to wear out the cutter. And actually, I didn't even compensate for the type of cutter, high-speed steel versus carbide. That was Dan's carbide insert doing this. So I just kind of wanted to give that feedback for everybody and say, yeah, feeds and speeds do make a difference. Just wanted to show this thing first. I had the magnetic base. It was only a few dollars off of Amazon. I'll put a link in the description to it. But it's pretty easy to do. You just remove the back. This was the back to this thing. I forgot where I got this actual indicator from, but this works great on the lathe. So I just undid the screws, put this guy on there, and I can put it right on the ways or wherever I want and check the travel here on the thing. So works out pretty good. This is a nice, oh yeah, I also tested this on the granite surface and it's right on the money. So I'm very happy with that. So on this thing, I had this nice chunk. I don't know where it came from. It's kicking around in the scrap drawer. One side's already been turned. So I thinking, well, what can I do with this? It's too small to, I don't know, do something with, but I started thinking, let me make a chuck stop. So I just kind of drew out, you know, figuring out if I'm gonna just take some material off of it. So kind of my initial thoughts are, it'll go on the rotary table. So I'm thinking, put this in the lathe, drill the center hole, a 1/4 inch, so that I can center it. Because I'll center the rotary table first with a gauge pin. Then the gauge pin drops in here and holds this in place. And I need it off the table. I need to find something shorter that I can mill right into. I don't care if I screw it up. I just don't want to hit the table. And then remember these clamps, guys. Nice low profile, guys. I got 4 of them, so I can put them in the 3 pieces that stay put and clamp it. So now I've got that. I don't think I need to finish this first or yet, face it. So I can use a drill bit and just kind of hog out most of the material, and then a 5/8 end mill. I can come in and clean it up, and that clears the jaws, because the jaws are thinner than this, so it's like perfect size. And once that's cleared out, I can look at it, and I can always come back and just cut little pieces off to make it look better. then I can use a 1/4-inch bolt or something and put it back in the lathe, and then face this and turn the outside. So this is thick enough that, oh, I was looking at it on the other jaws. These are these, but yeah, it needs to be faced down quite a bit more. Yeah, because these are, oh, these are the outside jaws, right? Yeah. So it's perfect for the other jaws that are in the lathe right now, the ones that I normally use. So I guess take it over to the mill and start doing it. I was thinking I could just use this. This is nice and low, and it doesn't matter if I hit it or not and cut into it. It's just a piece of scrap. So let's see what happens. All right, I'm realizing I've got kind of a problem here. I can't grab it comfortably or safely here with the 3 when I've got 4 90-degree slots here or whatever. So I'm thinking, all right, just put it down on the table, clamp it, and I can then just come in with the end mill and just get my reference marks. I can take it down pretty far. And then I can now independently just move it and say, all right, now I've got a groove, so I got a reference. Now I can just work the rest of this way. So I can remove most of the material here, and then I'll just have to clamp it and work one at a time to complete it and get it all cleaned up. So that's what I got to do. All right. I know that's not much light here, but the 1/8-inch gauge pin went in, centered the rotary. Then the 1/4-inch gauge pin went in, just left it down in there and put all the clamps in place. So it seems like it's rock solid. Now it's, I actually remember to zero out the DROs so I know exactly where I am on and 0. Okay, both of them are zeroed, because the x-axis unlocked the y-axis. 1/2 inch, I figure I'll just start with a 1/2 inch rather than the 5/8. Unlocked the wrong one. Do I have the, yeah, I have the clearance. I forgot about that. I don't have that much travel in the y-axis, so yeah, it's going to make it nicely. So I can start making my marks here and then rotate it I think it's 120. I'll have to do the math again, and then 120 and do the back one. So I remove as much as I can. I'll just guess is how far to go in, and then I'll check the number on the DRO, and so that I do the same distance on all of them. And that's about it. Just I did put a plate under there so I can clear this a little bit better, so I can take out as much material as I can. Wish I could get this camera in closer, but I went in, I'm 450 thousandths from the center. That would be to the center of this cutter, and this is a 1/2 inch, so that's pretty close. Seems like there's a lot of material here to just keep it all together. So now I'm trying to figure out, do I want to just keep doing this with the mill? Because I vacuumed it up. It's kicking chips everywhere. So, oh, sorry for my sniffing. It's cold. It's like 50 degrees out here. My nose is running. Or put a drill bit in there and just start removing the material. Not sure what I'm going to do, but probably, I know what I'm going to do. Take a break for a while. All right. Quite a few hours later here. I tried a bunch of different things, just dropping the mill in, and it's like everything was fighting. So drilling it was the best thing to do here. And once I got it all drilled out, then I just took, what was it? It's like a 3/8 end, a 3/8 drill bit. And then I ran a 3/8 back and forth going down, down, down to clear out the rest of the material. So now it's cleared out. And I've got the 1/2 inch back in there. And I'm realizing because of the clamps and this 3 thing, I have to do them one at a time. So it's pretty easy though, because you just get the magnifying glass, and since I had the 1/2 inch marks, all I have to do is spin the rotary until I'm on this edge, and then I know automatically I'm there. So now I'm just kind of dropping it down in and going back and forth, man, fairly light cuts, and then I'll put the 5/8 in there and do the final. But I'm going down about 10 thousandths here. Just kind of taking my time here. Clamps seem to be holding up really well. Using the Y-axis DRO to know how far back to go. I'm stopping 50 thousandths before because I figured the 5/8 I'm just going to do the final plunge to get a really nice back looking piece here. 7, 6, 5, 15, 8, 4, 3, 2, 1, close enough. Drop it down some more. So I know this is going to take a while to do, but oh well, that's the way it goes. And the next challenge would be figuring out how to make sure it's flat. So, alright, I got a ways to go here. Man, can't believe how close you gotta get. This camera is like 12 inches, or the phone is 12 inches away from the work. As you can see, the 2 back ones are done. I'm on the last one, finished the 1/2 inch here. So I gotta go to the 5/8 now and do the end of it. I went to the bigger clamps here because it allows me to take deeper cuts. It goes a lot quicker. And anything you can do, really, to try to be safer, do it, you know. So these guys are really solid. All right, so I'll change it out to 5/8 and finish this guy up. It's coming along pretty good so far. But it occurred to me, I never did check the face of the chuck here to see that how straight it is. Actually, I don't think you guys can see that needle. It's going to be crooked. Let me try bringing it up closer to 40 or something. Yeah, can I get it on 41? No. Ooh, 41. All right. Pretty good, huh? Yeah, 41. All right, so yeah, it turns out the chuck is pretty good here. It's, for the most part, staying where it's supposed to. There. So that's pretty good. All the way around. There. 41. Needle doesn't really move. So I can back this guy up. You can see, yeah, I've done some turning on it already. I've got to go quite a ways here. There's a spot not touched. Here's not touched. And here's a dent I got to take out. But I also realized I've got it way too thick for some reason for this guy. So I'm going to have to really face it off. Let me see. I think, no, I didn't turn it yet. So let's see if I can get on here. Get it back up close to the 40. Because I had it flat up against the chuck. And then I did do a facing. And then I just pulled it out because I'm starting to do the turning on it. Where am I? Yeah, that's about a thou under there. Whoa, that's way under. So yeah, I'm pretty crooked in capturing this thing. 5 thousandths. So here it goes way up. So I've got it. The other thing I discovered too, because I was going to use parallels here, the flat of them, you know, to try to get this thing mounted straight. Parallels are parallel, and they do come in pairs, and they are exactly the same size, but they're not the same thickness. So I got to figure out what I'm going to come up with now to do the facing so that I know it's really straight. So, and I've been turning it here with the tangential cutter because my main cutter, I don't know what happened, but it started giving me a god-awful finish. So I've got the height wrong somehow on it. So it's just a matter of doing some more turning here. Getting a little bit better at using this smartphone here for a camera. I'm trying the other lens, which is on the front or the back or whatever side. Do a little bit of turning, show you guys. I'm getting close to being, I can always fly cut this thing too to get it really straight. I just checked the trim on the mill and it's within a half a thou, so you're not going to get much better than that. Good and pounded. I wonder if the light does anything. Let's try it with the light for a bit. Go back slowly and clean up the face. Not taking anything off here. So, stop it. And the finish is pretty darn nice for this cutter. Wow. Yeah, I can go a little bit more on it. Turn the light off for a bit. You guys can maybe see better. So, getting there. Thinking about fly cutting it, but I really like the finish that this gives. So, let's see. Gonna hand walk the camera for now. You can see on the face here, if I can hold it still, I zeroed out, I put this thing on the granite surface and I zeroed it out right in here and then rotated it around, and I could see the +1 there. That was up 1,000th, and all the way where the dial indicator is was down 1,000th. So if you look at the needle here, as I rotate this thing, you can see the needle move. The reason I'm doing this is I wanted to test and see just how flat or straight or square or whatever these jaws are, and it's right on the money. When I rotate this around, I'm seeing and down 8,000th and then up 1,000th when I'm on the other one. So if I face it here, I know this part's going to be absolutely straight. And there it is, folks. 21 chuck stop. So I think it came out pretty good. I'm still going to take it over to the mill and countersink some holes and stick some magnets in it, but it came out pretty good. If I clamp the jaws down, it's going to skew it, so I got to just hold it right there. Let's give you guys a little view. It came out pretty darn flat, I think. Let's see, I guess I'll go to the 90 or 60, somewhere as close to that. See if I can get it on there. Ooh, right on it. So slight movement there, 1/10 or something. And if I can get it off and rotate it, there it is on the 60. So this sucker is pretty flat. That's like 1/10, maybe 2/10 above the 60. What's the last piece do? Oh boy, hard to hold all this. It's a half a thou up. No, yeah, it's bouncing. So no, it's not. You gotta hold it flat. It's 2/10. So I'm within 2/10 here flat, which is pretty nice, I think. But yeah, so I can clamp something. It just clears that jaw. Where's the thing here? What can I stick in there? Yeah, it's just, wow, just the end tooth there. Something to stick in there. What the heck? Huh? Why not? So with the magnets in place, it'll be really nice. So that should be held flat. Let's see what happens if I turn it on. Everything's clear. Yeah. Is it gonna wobble? Oh, that's this thing. Making a noise. Scared me. Yeah, it's wobbling a little bit. But I don't know if that part was really straight to begin with. What do I have that I can check that with? I don't think I have anything right here. that's known to be nice and straight. Oh well, so just have to put magnets in it and it's done if you guys want to bake one.